Hello there, and welcome back to the quiet edge of the universe. Tonight, we drift into the heart of the Milky Way, a place so distant, so dust-filled, and so drowned in darkness that no human eye will ever see it directly. Yet somehow, we know it's there, patient, silent, a presence older than every star you've ever wished upon. At the very center of our galaxy lies something extraordinary, something that bends space, slows time, and tugs at the fabric of reality with a strength our minds were never built to fully understand. Its name is Sagittarius A*, a supermassive black hole, 4 million times the mass of the Sunday, a creature of gravity so immense that even light, the fastest thing in existence, cannot outrun its pull. But tonight, we won't treat Sagittarius A* as a monster, not a violent beast tearing apart stars, but as a quiet giant, resting in the deep darkness, holding the entire galaxy together like a cosmic heartbeat. If you close your eyes for a moment, you might imagine drifting through the Milky Way's spiral arms, past clouds of cold gas, past newborn stars glowing in pink nebulae, past clusters of ancient suns still burning after 12 billion years, all of them slowly circling one single point, a dark anchor, a gravitational orchestra conductor, Sagittarius A*. To reach it, we'd have to travel through a region so packed with stars that night would never fall, because the sky would shine with 1,000 suns. In every direction, we'd pass objects moving at unimaginable speeds, rocks and gas whipped around like leaves in a storm. And then, in the quiet center of all that chaos, there is only stillness, not silence, not emptiness, but a kind of calm that only the universe itself can create. Black holes are not holes. They are places where gravity becomes so strong that space folds inward and time stretches like warm taffy. If you drift too close, seconds become hours, minutes become years. An entire lifetime can pass in what feels like a breath. And yet, Sagittarius A* is surprisingly gentle. It sleeps more than it feeds. It glows faintly, producing soft whispers of radiation as gas drifts nearby like dust in a beam of light. Astronomers call it quiescent, quiet, dormant, resting. Tonight, we simply sit with it, not to fear it, but to understand it, to float beside this cosmic titan and feel the soft pull of 4 million suns worth of gravity guiding the whole galaxy on its slow, elegant spin. So, settle in, breathe slowly, and let's begin our journey into the dark, into the calm, into the center of everything we know, into Sagittarius A*. Chapter 1: The Silent Heart of the Milky Way. If you could drift above the Milky Way and look down upon its swirling, silver arms, you would see a structure that looks almost alive, a soft glow of billions of stars, like grains of golden dust, slowly spiraling around a single point of darkness. Most galaxies have a center like this, a core where things become denser, hotter, and stranger. But the Milky Way's core is different, because at its center lies a presence so ancient and so powerful that everything else moves in response to it. This place is known as the galactic center, hidden behind curtains of dust and gas that stretch thousands of light years thick. Ordinary light cannot pass through it. Telescopes on Earth look toward that direction and see little more than a warm, dusty haze. And yet, through radio waves, infrared light, and high-energy signals, we've learned that something remarkable lives there. Right in the middle of our galaxy, wrapped in a cocoon of swirling stars, sits Sagittarius A times, a quiet giant with a mass 4 million times heavier than the Sunday. It doesn't shine, it doesn't sparkle, it simply exists, bending the world around it. Its gravity anchors the galaxy's shape, guiding the spiral arms like a conductor, guiding musicians through a slow, eternal song. Imagine drifting closer. The stars grow brighter. Space becomes thicker with light. Dust clouds glow like golden fog drifting through an endless night. This region is packed with stars, millions of them moving in orbits so fast they look like silver sparks tracing loops in the darkness. Some stars complete a full orbit around Sagittarius A times in just a handful of years. To circle the Sun takes 1 year, but to circle a black hole in the heart of the galaxy, that requires speed beyond anything we experience near Earth. There is one star in particular, S2, that streaks around Sagittarius A times at thousands of kilometers per second, 12 times faster than a bullet, and still it never escapes. Everything near the center is shaped by the same gravitational whisper. It is not a violent place, not the chaotic storm many imagine. It is more like a slow, steady heartbeat, a center of gravity so deep and calm that the galaxy has leaned into it for billions of years. For most of cosmic history, Sagittarius A times has been quiet, dozing, almost. Light trickles from the gas swirling around it, but the black hole rarely erupts or feeds dramatically. Instead, it rests, watching, holding. The strange thing is this: without Sagittarius A asterisk, the Milky Way would not have the same shape. The galaxy's rotation, its stability, even the slow spiraling of its arms, all of that depends on the gravity from the mass gathering in the core. In a way, this dark, invisible object holds the galaxy together, like the weight that keeps a spinning top balanced. Tonight, as we drift deeper into this mysterious region, we'll learn not just what Sagittarius A times is, but what it means to be a black hole. And so, with the soft glow of the galactic center growing brighter around us, we drift gently into Chapter 2. Chapter 2: What a Black Hole Really Is. Black holes may be the most misunderstood objects in the universe. When people hear the words black hole, they often imagine a cosmic vacuum cleaner, a ravenous monster devouring everything in sight. But reality is far quieter and far more beautiful. A black hole begins as a place where gravity becomes so strong, space has no choice but to fold inward. Imagine stretching a sheet of soft fabric and placing a heavy stone in the center. The fabric curves downward, forming a deep bowl. That bowl is like gravity, and the heavier the stone, the deeper the bowl becomes. Now imagine replacing the stone with something so dense, so impossibly heavy, that the fabric stretches all the way down into a narrow shaft that light itself cannot climb out of. That is a black hole. Not a hole in the sense of emptiness, but a place where gravity has gone beyond the limits of normal matter. At its center lies the singularity, a point of infinite density where the known laws of physics break down. Surrounding it is the event horizon, a spherical boundary where escape becomes impossible. Once anything crosses this horizon, it is lost to the universe forever, not destroyed, not crushed immediately, simply beyond reach. But here is the surprising truth. If the Sun suddenly became a black hole of the same mass, Earth's orbit would remain almost unchanged. we would simply continue circling, as always, pulled by the same gravity. That is because black holes do not suck. They attract, just like any mass does. Sagittarius A times is enormous, yes, but it is calm, controlled. Its violence exists only in imagination. Around it, gas swirls in a glowing, hot ring called an accretion disk, but even this disk is not always bright. Often it is dim, whispering rather than roaring. Some nights it flares gently as trapped particles spiral inward, heating up from friction. These flashes travel across space like little pulses, flickers of light from the hidden heart of the galaxy. But the strangest part of all is how black holes affect time. Near the event horizon, time slows. A minute for you may be an hour for someone watching from far away. The deeper you go into a gravitational well, the slower the clock ticks. A person drifting near a black hole and then returning home would find that the universe had aged more than they had acquired, cosmic magic predicted by Einstein. Black holes are not monsters. They are sculptors of space and keepers of time. They shape galaxies, influence orbits, and anchor the universe in ways we are only beginning to understand. And Sagittarius A*, it is the nearest supermassive black hole we will ever study this closely, which brings us to a question humans have asked for decades. How do we even know it's there? To answer that, we drift softly into Chapter 3. Chapter 3, how we discovered the monster we cannot see. For most of human history, the center of the Milky Way was nothing more than a glowing smudge in the sky, a warm, dusty band stretching overhead on summer nights. Ancient astronomers saw patterns in its stars, but they had no idea what lay hidden in the heart of that diffuse glow. Even the earliest telescopes showed almost nothing. The center of the galaxy was simply too obscured, too choked with dust for visible light to pass through. But in the 20th century, something changed. We learned to see in other kinds of light, radio waves, infrared beams, X-rays from distant cosmic events. These new tools peeled back the dust like lifting a curtain from a window, and behind that curtain, scientists found something extraordinary. In the 1,950 seconds, astronomers detected a strong radio signal coming from the direction of the constellation Sagittarius. It wasn't a star, it wasn't a nebula. It was something compact, powerful, and strangely bright in radio wavelengths. They named it Sagittarius A. A few years later, they found an even more intense source right at its center, a point-like beacon emitting a steady, concentrated signal. They called it Sagittarius A*, adding the little star symbol to mark its uniqueness, but they still had no idea what it was. The real breakthrough came in the 1,990 seconds, when extremely sensitive infrared telescopes began tracking the orbits of individual stars near the galactic center. These stars, though heavily obscured by dust, glowed just enough in infrared light to be mapped. What astronomers saw stunned them. The stars weren't moving randomly. They were whipping around an invisible point, loops and ellipses traced with incredible speed. Imagine watching leaves spiral around a drain. You may not see the drain itself, but you know it's there by how the leaves move. In the same way, scientists realized something massive, something unbelievably massive was pulling on these stars. By measuring the stars' speeds and orbits, they calculated the mass of the invisible object, 4 million suns, in a space smaller than our solar system and completely dark. There was only one possible explanation that fit every observation. a supermassive black hole. In 2018, this conclusion became undeniable when the Event Horizon Telescope captured the first ever image of Sagittarius A asterisk. Not a perfect photograph, not a crisp snapshot, but a glowing ring of radio waves bending around the event horizon, the unmistakable fingerprint of a black hole. After decades of mystery, we finally saw the outline of the monster we cannot see. And yet, the more closely we look at Sagittarius A asterisk, the more mysterious it becomes, which leads us gently onward toward Chapter 4. Chapter 4, the stars that dance around the darkness. If you could float near the center of the Milky Way and let time speed up like a time-lapse, you would witness something astonishing, a cosmic ballet unfolding in perfect, silent rhythm. Dozens of stars, some larger than our sun, some far brighter, move in tight, elegant loops around an invisible point. Their paths are curved like ribbons flowing around a drain. They speed up as they approach the center, then swing outward, slowing before falling inward again. This repeating dance is one of the strongest pieces of evidence that Sagittarius A times is real. And these stars are not calm, gentle suns like ours. They are young, hot, blue stars, the kind that burn fiercely for only a few million years. Their mere presence near a supermassive black hole was once thought impossible. The gravitational tides here should tear apart star-forming clouds before any new star can form. Yet the galactic center is full of them, clustered together like glowing embers. How do such fragile stars survive in such a hostile place? One idea is that they were formed far away and later migrated inward, drawn by gravity over long cosmic timescales. Another theory suggests that tidal forces near the black hole can actually compress certain gas clouds, igniting star formation right in the heart of the gravitational storm. And some scientists believe these stars may once have been older, cooler stars that were stripped, heated, and transformed by the extreme environment. Whatever the explanation, these stars gleam like jewels against a backdrop of darkness. Among them, the most famous is S2, the star whose orbit has been tracked for nearly 3 decades. It moves on a long, elliptical path, taking 16 years to complete one loop around Sagittarius A asterisk. At its closest approach, S2 races around the black hole at a speed of more than 25 million kilometers per hour. In that brief moment, it experiences gravity so intense that time itself slows down for it compared to the universe outside. This phenomenon, predicted by Einstein, was directly measured using S2's orbit. As the star whipped around the invisible mass, the light it emitted shifted in color, stretched by the warping of space-time. It was a quiet confirmation, whispered through photons, that general relativity holds true even in the most extreme environments we can observe. Other stars dance too. Some hug the center with incredibly tight orbits, completing a loop in just a handful of years. Others follow stretched, elongated paths, like comets caught in the gravitational tide. And deeper still, closer to the event horizon, there may be even smaller objects, dim stars, compact remnants, even planets whose orbits we have not yet resolved. We only see the brightest dancers. The rest remain shadows, moving in silent choreography around the giant that anchors them all. This dance has continued for millions of years, and it will continue for millions more unless something massive disturbs it, a passing galaxy, another black hole, or a surge of gas that awakens Sagittarius A times from its quiet state. But for now, the heart of the Milky Way remains calm. and the stars keep dancing. As we drift among them, glowing like blue fireflies in the deep dark, we move gently toward the next question. What happens to matter that wanders too close to Sagittarius A asterisk? Let's explore that in Chapter 5. Chapter 5. When a star wanders too close, it is surprisingly peaceful for something with the mass of 4 million suns. But every once in a while, very rarely, a star or cloud of gas drifts too close. And when that happens, the quiet turns into something far more dramatic. Imagine a star moving toward the event horizon. It begins as a normal sun, round, bright, complete, but as it falls deeper into the gravitational well, tides stretch it like warm dough. One side of the star experiences stronger gravity than the other, pulling it apart from within. These powerful tides create what astronomers call a spaghettification effect, not violent at first, but gradual, like dough being drawn into a thin ribbon. As the star approaches the point of no return, its material is torn into long streams that spiral around the black hole. Some of this material falls inward, lost forever, but some of it forms a glowing disk of hot plasma around the event horizon, an accretion disk. Temperature rises, magnetic fields twist, friction heats the gas until it glows millions of degrees. And for a brief moment, often lasting only hours, Sagittarius A times flares. Bright, powerful flashes of X-rays and infrared light escape from this swirling ring, erupting across space like cosmic lightning. These flares have been observed many times, each lasting just long enough to show that the black hole is awake. But these events are rare, so rare that many astronomers describe Sagittarius A times as starving. Unlike the black holes in distant galaxies that feed greedily on thick streams of matter, our central black hole lives a quiet life with little to eat. Occasionally, it pulls in a small cloud of gas or dust. Occasionally, a star gets too close and loses part of its outer layers. But full tidal destruction, a star being completely devoured, is likely an event that happens only once every 10,000 years or more. Still, we've caught glimpses. In 2019, Sagittarius A times brightened dramatically 10 times brighter than usual for a brief moment. Astronomers wondered if it had just torn apart a passing object, or if some stray clump of gas had fallen into its disk. We still don't know for sure, but the flare reminded us that the black hole is not dead, merely dormant. If a star were ever to be fully shredded by Sagittarius A asterisk, the galaxy would witness a tidal disruption event, a brilliant, terrifying flare visible across thousands of light years. Space would glow. The accretion disk would burn with incredible brightness. For months, maybe even years, the heart of the Milky Way would shine. But after the feast, the black hole would calm again, settling back into silence. These events show just how powerful Sagittarius A times truly is. Yet even they are only moments, brief flashes, in a cosmic night that lasts billions of years. And so we drift now to a different story. The story of how this giant came to exist at all. This brings us gently to Chapter 6. Chapter 6. The birth of a monster. Long before the sun was born, before Earth existed, before the Milky Way even formed its graceful spiral arms, something dark and heavy was already growing in the center. Sagittarius A times did not appear suddenly. It was built slowly, patient, and quiet over billions of years. The story begins in the early universe, just a few 100 million years after the Big Bang. when the cosmos was filled with the first generation of stars. These ancient giants were massive, dozens, even hundreds of times more massive than the Sunday. Their lives were short, their deaths spectacular. When the biggest of these first stars died, they collapsed into black holes. Most were small, only a few times the mass of the Sunday, but some became seeds. Black hole seeds. Astronomers call them the tiny cores from which supermassive black holes eventually grow. One of these seeds might have found itself in a dense pocket of matter near the center of a young, forming galaxy. There, gas and dust swirled inward, stars collided, clouds merged. Gravity gathered everything like a slow carousel of creation. As the seed consumed more mass, it grew heavier. As it grew heavier, it pulled in even more matter. This positive feedback loop continued for millions of years. But this alone cannot explain the speed at which some black holes grew. And so another possibility emerges. Some scientists believe Sagittarius A times formed from the direct collapse of a gigantic gas cloud, a cloud so massive that it skipped the star-forming stage entirely. Instead of breaking into stars, it fell inward all at once, creating a black hole tens of thousands of times the mass of the Sun in a single moment. From there, cosmic time did the rest, merges with other black holes, steady feeding from dense gas streams, occasional star clusters spiraling inward and falling apart. Over billions of years, Sagittarius A times reached its present size, 4 million solar masses. But here is the surprising part. It could have been much larger. Most galaxies of the Milky Way's size host central black holes hundreds of millions, even billions, of times heavier than the Sunday. Ours is relatively small. Scientists are still unsure why. Maybe the Milky Way never experienced the galactic collisions that feed central black holes. Maybe the gas supply simply ran out billions of years ago, or maybe Sagittarius A times is only resting, waiting for the next major feast. Its story is long, slow, and filled with mystery, a history written not in light, but in gravity. And now, having learned how this giant was born, we drift deeper into the question, what will Sagittarius A times become in the far future? A quiet inhale, and we continue onward toward Chapter 7. Chapter 7, the future of Sagittarius A*. When you look at Sagittarius A times today, it feels ancient, a titan that has been sleeping in the dark since the dawn of time. But even giants evolve, even black holes have futures. And though these futures stretch across billions of years, we can still imagine the long, slow changes that await the monster at the center of our galaxy. For now, Sagittarius A times is quiet. It feeds only occasionally, glowing gently when a stray cloud wanders too close. But this calm cannot last forever. The galaxy around it is constantly moving, stars drifting inward, clusters falling apart, gas clouds spiraling in unpredictable paths. Over millions of years, some of these objects will inevitably find their way into the black hole's reach. When they do, Sagittarius A times may awaken. Imagine a future where a giant molecular cloud, thousands of times more massive than the Sun, passes near the galactic center. Gravity stretches it, tears it, funnels it into a disk that blazes with light. As it falls inward, flares erupt. The quiet heart of the Milky Way brightens until it becomes a quasar-like beacon. For a short cosmic moment, perhaps a million years, Sagittarius A times might shine with incredible intensity. Then, as the food supply dwindles, it will fall quiet again. Farther into the future still, our galaxy will approach a destiny written in the motion of the stars, a collision with the Andromeda galaxy. In roughly 4 billion years, the two galaxies will merge in a slow, graceful dance. Their stars will pass through each other like soft clouds, rarely colliding, but their central black holes, those will meet. And when they do, Sagittarius A times will no longer be alone. As the two galaxies intertwine, their central black holes will spiral toward each other, losing energy through gravitational waves, ripples in space-time itself. Slowly, patiently, the giants will draw together, and after millions of years, they will merge into a single supermassive black hole, far larger than either one alone. This new black hole will sit at the center of the merged galaxy, a galaxy sometimes called Milkdromeda. Sagittarius A*, even in its distant future, will continue to grow through quiet feeding, through mergers, through slow accumulation. Black holes do not shrink, they only grow, even if that growth is almost imperceptible on human timescales. And in the very, very distant future, trillions of years from now, long after the last stars have faded and the universe grows cold, black holes will be among the final structures that remain. Sagittarius A times may persist almost forever. It will outlive our Sunday, our planet, our species, even the galaxy as we know it. But its story, long though it is, connects intimately with ours, because without Sagittarius A*, the Milky Way's structure would not exist, and without the Milky Way, neither would we. Now, with the future settled softly around us, we turn to something deeper still, the strange ways Sagittarius A times shapes space and time themselves. Let's drift onward to Chapter 8. Chapter 8, How Sagittarius A times warps space and time. To understand the true nature of Sagittarius A*, you must imagine space not as an empty void, but as a soft, flexible fabric. This fabric can stretch, curve, ripple, and twist. Everything with mass presses into it, stars, planets, even you. But a black hole is a weight so extreme that the fabric stretches downward into a deep well from which nothing can climb out. Near Sagittarius A*, this curvature becomes so intense that normal rules begin to dissolve. If you floated near the event horizon, not crossing, but hovering just above, you would witness something surreal. Light from the stars behind you would bend around the black hole, forming arcs of brightness. Space would curve so much that you could see objects not by looking around them, but by looking past the black hole, where gravity lenses the light like a cosmic mirror. This phenomenon is called gravitational lensing, and it's one of the ways scientists confirmed Sagittarius A*'s presence. Light bends around it, tracing the shape of the unseen. But gravity's influence goes deeper than bending light. It bends time. Near Sagittarius A*, time moves slower. A clock ticking near the event horizon would fall behind one ticking far away. A person lingering in this deep well of gravity might return to find that years or even centuries have passed outside, while only days passed for them. This is not science fiction. This is general relativity. What seems like a gentle, continuous flow to us, seconds following seconds, is not universal. Time is elastic, stretching and compressing depending on gravity's pull. The closer you move towards Sagittarius A*, the more time slows. And if you were to fall through the event horizon, something even stranger would happen. From your perspective, nothing special occurs. You simply drift inward, following gravity. But from the outside world, you would appear to freeze on the edge, your image stretched and reddened, fading slowly into the dark. Inside the horizon, space-time is so curved that every path leads inward. Space moves like a river, flowing toward the singularity, and time becomes a direction pointing only toward the center. No force, no engine, no wish can pull you back. Yet despite these extreme distortions, Sagittarius A times remains gentle from afar. Even a supermassive black hole has a surprisingly wide event horizon. Falling into it would feel calm at first. Only near the singularity does the gravity become fatal. But studying these distortions is not just theoretical curiosity. It helps scientists test the limits of physics to explore where Einstein's equations hold and where they might break. Sagittarius A times is not just a black hole. It is a laboratory for space-time itself. And as we drift deeper into this cosmic mystery, we reach a question even more personal. Could anything survive near Sagittarius A asterisk? This brings us softly into Chapter 9. Chapter 9. What would happen if you fell into Sagittarius A asterisk? Humans have always been curious about the unknown, and few mysteries spark as much imagination as falling into a black hole. The truth, though rarely told simply, is both terrifying and strangely beautiful. If you drifted towards Sagittarius A asterisk, the first thing you'd notice is nothing. Space wouldn't tremble, lights wouldn't flicker, you wouldn't feel a sudden pull. Supermassive black holes have such large event horizons that the change in gravity across your body would be incredibly gentle. No stretching, no spaghettification, not yet. You could drift right through the event horizon without realizing it. From your perspective, the universe looks almost normal. Stars still shine. Time flows forward. You continue falling, calmly, silently. But to the outside universe, to cameras observing you from afar, you would freeze at the edge. Your last image would stretch and fade as light struggles to climb out. Once you pass the horizon, no signal escapes, no message, no light, no sound. Inside, space pulls you inward like a river flowing toward a waterfall, except you cannot swim upstream. Every path, every direction, every future leads to one place, the singularity. As you approach the center, gravity becomes impossibly strong. Tidal forces stretch you, atoms elongate, matter unravels. At some point still far inside physics as we know it ceases to exist. Einstein's equations break, quantum mechanics struggles, time and space fold into something beyond our understanding. You do not survive, but your atoms become part of the black hole. Your mass contributes to its growth. You join the darkness, not erased, but transformed into pure gravitational influence. It is not a violent end. It is quiet, silent, inevitable. And yet, this finality hides something profound. Everything that falls into a black hole adds to its story, just as everything that falls into Sagittarius A times becomes part of the force that holds our galaxy together. But falling in is not the only way to reach the singularity. Some objects spiral in gradually, others scatter near the horizon for eons. The journey varies, but all roads inward share one truth. Black holes do not destroy matter, they change it. They compress its history into gravity, which leads us to our final chapter, the role Sagittarius A times plays in the life of our galaxy. Drifting softly, we enter Chapter 10. Chapter 10, the black hole that holds our galaxy together. Sagittarius A times may seem like a distant giant, indifferent to the stars that orbit it, but its influence is woven into the very structure of the Milky Way, a quiet architect shaping the galaxy we call home. Its gravity anchors the core. Without it, the central stars would scatter. The dense swarm called the bulge would loosen. The spiral arms might unravel over billions of years. Sagittarius A times gives the Milky Way stability, but it offers more than structure. It offers energy. The region near the galactic center is one of the most dynamic places in the galaxy. Clouds collide, stars are born, gas is heated and flung outward in enormous arcs. Black holes generate magnetic fields, radiation, and high-energy particles that help regulate the flow of matter across the galaxy. Some scientists believe that Sagittarius A times helped shape the early Milky Way, influencing when and where stars formed. Others think the black hole's gentle flares help prevent gas from collapsing too quickly, balancing star formation over cosmic time. Even now, Sagittarius A times continues to shape the galaxy's rhythm. Its gravity helps shepherd stars on long elliptical paths. Its past eruptions may have blown giant bubbles of hot gas thousands of light years tall, structures we can still detect today. And its very presence influences the motion of stars thousands of light years away. We often think of black holes as destroyers, but the truth is gentler. They are stabilizers, organizers, anchors. Without Sagittarius A*, the Milky Way would be a very different place, possibly a less stable one, possibly one without the calm, gentle cradle that allowed worlds like Earth to form and thrive. The black hole is not a monster. It is a root, a gravitational root that keeps the galaxy grounded in its slow rotation, a dark center that gives shape to light, a hidden influence that makes life, in its own distant way, possible. Tonight, as we drift away from the galactic center, we leave with a quiet understanding. The universe is held together by things we cannot see, by forces beyond light, by giants that sleep in the dark. And Sagittarius A*, patient, gravitational, eternal, is one of them.